Welcome to our fourth in the series of videos, iHuman. This is about robotics, AI, healthcare, human values, and human futures. We're going to look at robots in the context of healthcare applications and also AI applications too. In terms of robots, often they're used as care assistants, perhaps for the elderly, as well as providing physical support, maybe carrying patients, moving patients, and so on. In future, perhaps they'll be used for treatments, including injections, and certainly in the area of physical therapy to assist in recovery. In AI, diagnostic applications are becoming commonplace. Data analysis of medical records, diagnostic assessments, medical education, and prominently in all of this, we see IBM's Watson supercomputer being used in conjunction with major hospitals. Here we see Toyota's Care Bear. The bear is assisting a nurse to lift a patient. Scrap that. Here we see Toyota's Care Bear assisting a nurse to lift a patient. Very much a partnership between the human and the robot that seems pretty effective. In this instance, with the view of some patients in a Chinese setting, we have two little care bots who are substituting for human beings. Are they saying, I care, I really do care? How do we square this idea of human value with replacement of human beings by robots? Are we talking here human value or just value for money? Here again we have the robot Care Bear lifting a patient into a wheelchair, and this is particularly used in Japanese facilities, nursing facilities. The problem has been, though, since 2017, that the take-up of the robots is still only running around 8 to 10%. Cost and negative reception by the human patients and the caregivers explains this poor take-up considerably. Of course, if robots were to actually replace nursing staff, we might increase accuracy, there might be fewer errors, certainly there would be cost savings over time, but we're moving into this problem. Are automated treatments provided by robots simply replacing human interaction with machine interaction? Are people commodities, just like cars? Here we see a visual image from a movie called Robot and Frank. Here you have an Alzheimer's patient who's been offered a carer in the form of a robot. Raises the whole question of whether caring is just a science or does it involve a human dimension by definition. Can the carebot learn how to do better? Yes. Can Frank teach the robot how to do foolish things because of his dementia, maybe even to misbehave? On the right-hand side, you have the socially assistive robot, which is helping a patient with physical therapy. Again, the question might be, is therapy just a science? What's the real value of the human touch in caring for Frank or for the person in physical therapy? AI and diagnostics. Looking at the recent research in this field, we find that artificial intelligence has often proved more accurate than doctors in diagnosing subtleties in breast cancer as a result of reviewing mammograms. A recent study in the journal Nature suggests that an international team of researchers have actually shown this to be the case. The algorithm outperformed the radiologists in reading the mammograms. So the question might be, ought we to be incorporating AI diagnostics with the human observational element? And the answer seems to be yes, this is going forward rapidly, particularly in areas of cancer diagnosis. Another possibility of AI is to look at the application of biochips. Biochips could be implanted or they could be wearable. If you have an implanted biochip, it's going to be put under your skin, probably in your hand or maybe behind the neck. And essentially what it does is it communicates with an external reader and provides information about your medical condition. There are privacy concerns with these issues. Could you have chips that were just simply GPS surveillance? Could this be a way of preventing prisoners removing their ankle bracelets and so on? On the other hand, of course, biochips can be worn as a Fitbit or an Apple Watch, perhaps, and reflecting this concern for monitoring your medical conditions, whether it's from a sports point of view or from a medical condition. Here we see the actual chip, the biochip. Its implantation into somebody's hand, and the actual size, which is really quite small. It's about the size of an uncooked grain of rice. Implantation is pretty simple. Removal is also fairly easy to do. You can see how this mirrors some of the developments in implantation of pacemakers traditionally that are getting smaller and smaller. Another application for AI support is in the area of children with autism or other disabilities, where it might be important to keep an eye on them and to track them. Obviously, you can provide such a student or child with a mobile phone and keep in touch. But here's a new idea from Independence Day Clothing. They are including pockets carefully concealed for miniature tracking devices to be inserted, as we can see here. Here, AI is clearly supporting both health and the value of the human person. The other side of the slide, we see the Fitbit, the traditional Fitbit, where personal health and sports data can be monitored as a matter of personal preference, but also as a result of medical advice and monitoring. We look at the volume of data that's around. It's not surprising that AI becomes an important feature in healthcare. IBM has developed the Watson supercomputer, and here we see in this slide a picture of it and also of the contestants that tried to beat it on a special version of the TV series Jeopardy back in 2011. Watson beat the human contestants pretty handily. The Cleveland Clinic is one of many hospitals that has used Watson actively for their research and is currently undertaking a long-term project to teach Watson to, quote, think like a doctor. On this slide, we see an analysis of the overload of data facing healthcare professionals today. A vast amount of the medical information available to healthcare professionals is basically unstructured. The volume of data is enormous and rapidly expanding, perhaps at the rate of 200% in the next 2 years. Some people claim that 90% of the data that's existing today was actually created only in the last 2 years. In terms of medical research, there are about 75 clinical trials starting every day just in the USA alone. So from the point of view of analysis of data, Watson could be pretty useful, especially in relation to diagnostics. It's estimated that inaccuracies or incomplete diagnosis take place in approximately 20% of all patient encounters. So here we are looking at how Watson might be used. The physician has inquiries, puts them through Watson. Watson looks at the input and analyzes it, and then provides potential diagnoses as an output. Let's look at some of the innovations Watson is involved with. There's a major partnership between IBM and the Cleveland Clinic in Ohio to develop various medical applications, and I highlight here 4 of them. First of all, attempts to get positive assistance from and insights from the electronic medical records in a quick summary of vast amounts of data. The second project is a genomics project looking at the genetic makeup of patients and how to collect together the cancer treatment data. Third one has to do with symptom analysis. And here we're looking at some of the educational aspects of Watson. It's an integral part of the new healthcare campus at the Cleveland Clinic in coordination with the local Case University Medical School as well. And then as a result of this medical innovation partnership, there's been a spin-off of a major corporation, the Explorisys company, which has actually been so successful that it's been bought back by IBM from the Cleveland Clinic.